Okay, inside the radical we get 16. Whenever you're doing one of these questions, it should always be positive. You can't take the square root of a negative. If you get a negative, you probably entered it wrong in the calculator. Double check. If that does come out to be negative, that means there's no solution. We'll talk about that one later as well. So now we'll evaluate the radical, and then we can find our two answers, negative 20 plus 4 divided by negative 4, and negative 20 minus 4 divided by negative 4. We're going to get x equals 6, and x equals 4. Now, a little more advanced way of looking at this is all three numbers in this equation are even, and the leading coefficient is negative, which you never want to have. So if we divide everything by negative 2, it'll make the equation easier, in this case, factorable. So we'd have x squared minus 10x plus 24 equals 0. All right, we can factor this. X minus 6, x minus 4 equals 0. And you get your 6 and your 4. Now, in the second example here, you get a kind of a word problem, if you will. So this function used to represent the height of some projectile, who knows what it is, launched from a cannon. All right, we're going to find the zeros algebraically. Okay, so we're going to use a quadratic formula again. In this case, the variable is t, so it's t equals. Now, I'm going to do the same thing I did last time. I'm going to divide everything by negative 2. So we'd have t squared minus 6t minus 16 equals 0. T minus 8, t plus 2. Now, if you did the quadratic formula, you would get the exact same numbers, same signs, everything. It would just take a little longer. All right, so if you don't look at factoring, it's not going to hurt you. It'll just take a little bit longer. Now, we're going to explain the meaning in this context. Okay, t equals 8. That means the object is in the air for 8 seconds. T equals negative 2. There's our negative time, which we don't have, so theoretically, the object would have been launched 2 seconds before it was. So at negative 2, it would have been launched theoretically, and then it would have hit right here at 32. The graph goes up, comes down. This is the actual tracking of the height, not the path, just the height. And it would reach the ground at 8 seconds. Okay? So we don't take into account the negative time. Okay, now on for the concavity part of this here. Again, concave up, concave down. If you have something that's concave up, that's like a regular parabola opening up. The slopes of the tangent lines